Hello, hello everyone. Uh, Nice to meet you all at our Mobile People Flutter event. Today, uh, today's talk will be interested not only for Flutter developers, as you will see in the description, and even not only to mobile developers. It should be interested for everyone. Native mobile developers, uh, cross-platform developers, backend developers, and even front-end developers. Uh, Today, we will take a look to the framework a little from the side and show what the current in the current moment can be done with it. And which benefits it gives to us. Just recently, Flutter 3.0 was released, which allows us and you to develop applications for 6 platforms at once using Flutter. And so, let me introduce today's speaker. He's Maxim Saplin. He will be our speaker today, yes, and he tell you about his experiments with Flutter and Flutter on different platforms, and comparison Flutter with other frameworks and with native development. He even used a benchmark implemented by his own self. So, hello, Maxim.
Hello. Okay, so
can you see me? Okay, good. Can you tell to watchers about yourself, probably? How did you decide to make your research about Flutter and so on?
Okay, yeah. Well, probably let me start by explaining this ambient computing term, and then I'll do a short intro. So ambient computing, that's the term I believe coined by Flutter team. The essence is that nowadays we've got a wide range of various form factors, devices, platforms, kiosk, mobile phone, desktop, computer, and why don't we have same or similar user experience across this wide range of platforms? And Flutter, it provides the tools to build this kind of user experiences. So my name is Maxim. Currently, I work as a delivery partner at EPAM, which is a managerial role. But still, why am I telling you about this engineering topic here? So I started my career as a .NET developer 14 years ago. Why I might be qualified to tell you about mobile development and Flutter. I used to spend my time doing some hands-on work with .NET, Xamarin. I have experience with JS, React, and recently Dart and Flutter. I have a number of pet projects. I do contribute to Flutter, and I believe that I've formed some perspective which I am ready to share. And I guess I can give an intro to any software developer who might be curious about learning what Flutter is and deciding to jump onto this project. I have a number of...
Sorry for interruption. I just wanted to add to our watchers. During the talk, if you have questions, feel free to type your questions in the comments, and after the talk, after the demonstration, we will come back to the questions and try to answer to them together with Maxim. Sorry, and I'm leaving.
Okay, yeah, so, and just to provide some evidence that I know a bit about the subjects, I've got 3 apps published to Google Play. One of the apps is Xamarin app. It has over 250,000 downloads already. One of the apps, Dict, I will show you later, it's based on Flutter. Besides, there is this package called data table 2, which is published to PubDev. PubDev, that's the package manager for Dart and Flutter. And it's among the top 2 most liked packages at this package manager. So yeah, that's it about me. And to start, let me present you with a little show, attraction, that's what I call it. So currently I've got an iOS emulator, I got Android emulator, I got VM running Windows 11, I've got a VM running Ubuntu, I've got a debugging session started for a macOS native app. I've got this, pardon me, somewhere. I've got this app open in browser. Already lost it. Yeah. And it's up and running. Working is the same project, fully functional. You can see that it's like pixel perfect presentation with the difference of some system stuff such as title bars, but still like that's exactly the same app, and that's what Flutter is calling to be in ambient computing. So I've showed you something like 7 platforms, I believe. Let me start closing these VMs. They're quite hungry. And if we go and check iOS simulator, yeah, that's again the app is up and running. There is another, I would say, bonus platform available to any app built with Flutter. You can add the app to home screen, sorry for the Russian language. And here you go, you've got this PWA, Progressive Web App, ready to use and looking exactly the same without any address bar, etc. Yeah, so that's it with this traction part. And the key point is that all of those platforms, they are built from the single code base. It's 92%. That's, by the way, the screenshot from GitHub, where the project is published. So that's built once, run as many times as you want, at as many platforms as you wish. And all the rest pieces such as C#, HTML, etc., those are auto-generated parts. That's the boilerplate code created for you by the framework. And by the way, I used Flutter to build my dream dictionary app. Probably some of you know that there is such program called ColorDict available for Android. That's essentially the same idea, but it's tailored to one-hand use with the UI focused around the bottom part of the application. That's the application. Okay. And before we dive into some other topics, I think it's important to show you around the code structure for this specific app, which is currently being executed. It's actually easy. Like any Flutter app, it starts with pubspec.yaml file. That's where you have all your dependencies, all your settings for some of the plugins you might add, some metadata such as name, versions, etc. That's where you define some of the assets. So that's the file which resides at the root of your project folder. Then we got this lib folder. That's the single code base. That's where all your Dart code lives. That's basically where you spend 99.9% time as a Dart developer creating your UI and business logic or whatever. And that's the entry point, main dot. That's where your app starts its life when it started. And just like in other cross-platform toolkits such as React Native or Xamarin, each platform has its own platform project. For example, if I open this macOS folder, we can see that there is this Xcode project, which can be opened in Xcode. You can even change something if you wish, but still, like that's the way it works. You still need some native components, you need native projects, and Flutter provides you with some embedders, some classes, which you then use in order to embed your lib or whatever into this native project. And by the way, if I stop the project, you can see that right away for macOS, for this single platform, I can build and run the application for four platforms: iOS, Android, Web, and macOS native. Okay, that's the quick intro of the Flutter project structure. We recap: pub spec YAML, lib with single code base, and folders for each platform that we target. And the rest, that's something you might explore if you start playing with Flutter. Okay, another topic is, that's my take on to systemizing, trying to create this categorization of different cross-platform toolkits based on the concept how they do the rendering. That's my take. It might be not perfect, but still, like we got a number of frameworks such as Electron, PhoneGap, or even PWA. And in those cases, we have some native app which has a web view, some web browser embedded as a full screen control. And then we've got bundled assets with HTML and JS, and these frameworks, they create all the necessary bindings, integrations, bundling, etc. We're essentially wrapping our web apps into native apps and use full power of modern browsers in order to render UI. And also they provide some APIs in order to integrate with native stuff such as cameras, sensors, galleries, etc. The second category, that's native renderers. That's how React Native and Xamarin or MAUI work. In those cases, we've got this abstraction of some UI visual elements, components. It doesn't matter what is the name, but these frameworks, when they create native projects, they try to find some analogies, some counterparts among native controls. So, for example, if I put Xamarin's label on a form, then the native part checks, okay, I've got text view, for example, on Android, and I will use this text view in order to render this label. Same for React. It simply tries to map those general UI building blocks to native controls and components, and does the rendering using native APIs. And by the way, for Xamarin, some time ago, that was a kind of selling point for them. They promised to have UI to look the way it is supposed to look. For example, on Windows Phone, you might have some tabs at the top. On iOS, you might have those tab views on the bottom, because that's the way it works. It's simply found whatever is the closest to the given control. And the third category, that's canvases. That's where Flutter falls. In this case, the framework, they take the bare minimum from the platform, say, give me some place to draw, a window, a canvas, or whatever. Give me some basic stuff for user input, mouse, touch, keyboard, etc., and I'll take care of putting pixels on the screen. And that's probably the key difference. With native renderers, you might expect to have this challenges with UI defects when something is broken or something is not looking as expected at a given platform. While canvases, it in most cases provides you this pixel perfect rendering across all the platforms. Okay. Dope test. Actually, that's a small story about how I got acquainted with Flutter. Back in 2020, I read an article about yet another release of Flutter and performance improvements. I haven't used Flutter or Dart by this time, and I decided, why don't I put to test this claim that it's super performant, and why don't I create this micro benchmark when I use the capabilities of various platforms in order to put text at random positions with random rotation, color, and count how many of these labels I can put in a given second. And bear in mind that that's not a simple canvas text out. That's actually the UI pipeline. We've got Z indexes. We've got maximum of, if I'm not mistaken, 800 labels in the screen. And as soon as I add yet another label, the previous ones, they should disappear and that index should preserve. So that's actually a test which puts to test the whole rendering pipeline, how the framework deals with locations, etc. We can actually play a guess game where is a specific platform, but we wouldn't do this because we don't have this interactivity. So we've got Xamarin Forms to the left. It managed to show only around 120 labels put in a second. Then we've got Flutter, which was super fast, 12,000 labels put to the screen in a given second. Then we've got plain.js around 3,000, and we've got React. Okay. While doing this dope test, I decided why don't I also add Android native Kotlin app and see how it does. It didn't do well, and there was some unexplained to me performance degradation. Like it started with 3,000 and over time dropped to 300. Asked other fellow Android developers, no one came up with the explanation. Also, while checking and benchmarking these three ways to build native apps, Xamarin Forms, Flutter, and Kotlin, I decided to check some of the attributes of the produced applications. So for example, Xamarin Forms dope test app built for 3 architectures with just-in-time compiling. Side note, Xamarin Forms also supports ahead of time. That's not default. So in this note, Xamarin Forms app took the APK package was 20 megabytes. After the app was installed, it took 47 megabytes of the storage on the phone. And if you use ADB to measure the launch time, it took 730 milliseconds. For Flutter, we have 15 megabytes APK. We got 29 megabytes install size and just 280 milliseconds to launch the app. Like in all departments, it did much better. And for client native, or Kotlin and native Android app, since there was no any native libraries embedded into APK, that's just 2 megabytes, 6 megabytes installed, and 190 milliseconds to start. But still, like not looking at the sizes of APKs, launch time is measurable and comparable for Flutter and for Kotlin, which I believe is a good sign. And by the way, if you happen to deal with App Store optimization, publishing the apps to stores, you might come across this recommendations to decrease the APK size, to decrease the launch times. There are these Android Vitals sections which allow you to track this, because there is a research showing that statistically there are better conversions from downloads for keeping the app installed and using it if you have sizes minimal and launch times minimal. So yeah, that's important. Okay, and by the way, currently, like if you go to Google Play and would like to publish, you wouldn't use APKs, you would use bundles. That's a better way to deliver tailored packages to given devices. Okay, and let's talk about Dart. So as you remember, we had these two words, the title Dart and Flutter. Dart, that's the programming language. That's how you build console apps, and Flutter, that's the framework which uses Dart as a language which Flutter developers use to build the UIs. But let's spend a bit on Dart specifically. Like Dart as a programming language, it's quite young, early 2010s. And by the way, it was supposed to be a replacement for JavaScript in Google Chrome, but it didn't play out well. So Dart is, I would say, very simple. If you compare it to some monsters such as C#, it's way simple. Everything is an object. When you create an object, you don't have to use the new keyword, which makes sense, and you will see why later. There are very few built-in types. All of those are present here. And for example, you don't have flavors of integers or doubles based on the variable size. Like you just get int, and you don't care whether it's byte, 4 bytes, etc. You don't have access modifiers such as private, public, protected. You only have underscore, which kind of private modifier with some tricks. In Dart, there are no interfaces such as in Java or C#. There are only abstract classes. One curious stuff which kind of attracts my attention, there is one correct code style, at least when you are using Visual Studio. Whenever you click Save, the formatter applies the styling, removes unnecessary line breaks, etc. So unlike other languages, it does quite aggressive code styling upon each file saving, which could irritate at the beginning, but later you actually can see comfort in this. In Dart, there are no threads, there are isolates, which is close to background workers in JavaScript. So if you want to have concurrency, you create an isolate, you communicate with isolates via messages, streams, which receive these objects, and then you've got some overheads associated with marshalling objects between isolates. Each Flutter or Dart app, they start with a single main isolate, but you can spawn other isolates. You might read that Dart is single-threaded, just like JavaScript. That's actually not true. There is one thread available to the developer, but actually there are threads which do some stuff behind the scenes, such as garbage collection, async input-output stuff. If we're talking about Dart, we're talking about Flutter, then there is a rendering thread which takes care of putting pixels on the screen. Okay, another thing that there is no reflection in Dart. Effectively, there is some reflection capabilities in virtual machine of Dart, but there is no such capability in ahead of time. And all Flutter apps, they when they are built in release configs, they are all ahead of time. We can touch this a bit later, the difference between VM and ahead of time. There is no preprocessor for Dart, and if you are looking for if, def, etc., or build configurations, you wouldn't find. And there is actually an issue at GitHub with many comments, which is already several years old, but who knows when and if there will be such feature. Dart features. Garbage collected. They claim that it has a runtime optimized for fast allocations and managing multiple small objects, which makes sense because that's what you do when you use Flutter. You create plenty of objects. There are constant constructors, and there are named constructors. Constant constructors, they're supposed to be super quick and fast and keep CPU cycles in the runtime, and named constructors that just a syntax sugar. We'll see how it works later. There are generics and extension methods. There are positional and named parameters. So yeah, we'll look into this. You can use mixins, so in order not to keep an inheritance slot busy, but if you want to have some stuff mixed into your class, here they are. That's, for example, for animations, that's the way Flutter suggests to use those. Async await features and streams, those are language features that were in the language from the very beginning. Again, isolate for concurrency, I already told about this. And Dart is sound type and null safe language. And there was quite a lot of buzz and quite a lot of, I'd say, agitation about this null safety last year. That's when Dart made this move from not null safe to null safe language. And we can touch it probably when we look at the code. But the point is that if you introduce certain language disciplines integrated and being part of the language, then you can avoid null checks added behind the scenes by the compiler into the bytecode, native or machine code, because like language guarantees there is no condition when an object being accessed might be null. And if in Java or C# you might get this null reference exception when you use the dot and then access some member with sound null safety, that doesn't happen. And the promises are lower code size and faster code. And from this table by the Dart team, they say that there are not that many languages which offer this feature. Okay, let's be practical and let's look into some simple example of Dart code. By the way, Dartpad, that's a web app which allows you to run the bug test apps in the browser, both Dart apps, console apps. It also can build Flutter UIs, and you can see right away the UI built here. Okay, but let's talk about Dart. So import, that's how you reference packages or reference other files from your project. That's how you define a stream. Know that it starts with the capital S, difference from C#. You can use both single quote or double quote. But Dart recommends to use single quotes. That's how you define classes. That's the attribute class. That's how we define a method using an arrow function. And that's how we define this same method using the standard brackets for the method. Okay, so here we got these three classes. That's how these inheritance and mixins work. Extends, that's when we inherit from a class. With, that's when we mix some members into the class. implements, that's again an inheritance, but in this case, we only inherit the contract, the definitions of the members, methods, or properties, but we are required to create the implementations for all the methods. Okay, and let's look at constructors. So that's the constructor. Here we can see the positional argument, and it references right away a class member. That's a shortcut. That's how you initialize a read-only or final member upon creation, which cannot be changed afterwards. Then we've got this named parameter. And that's, by the way, how you call a named parameter. That's the difference. Like conditional parameters, you just write the value, and with named parameters, you should put in the name. And why it's used in Flutter, like when you create some widgets, you might have tens of these parameters, but you might want to override just a few of them. That's why you use these named parameters and keep other params with their default values. Okay, let's look at the body of the constructor. That's how we initialize an internal private. If you remember, I told you about this underscore stuff. Internal field, though. And if, for example, I do import this file in some other file with this word import, this member won't be visible. If I defined other class in this exact file, so like the scope of visibility underscore, they are visible within a single file, but they are not visible outside this file. That's how this underscore private access modifier works. Okay, again, that's how we initialize a list or array. Like you don't have arrays in Dart, you've got lists, but still, like no one forbids us to use something familiar to us, such as square brackets. And again, I can see, like with this double single quotes, use or not use the new keyword. The creators of language, they try to make the language as convenient for someone coming from C like languages such as JS, C#, Java, just to make sure they don't stumble across some trivial stuff. Okay, that's another example of a constructor. That's a named constructor, and as you can see in this named constructor, we call our default constructor and use some predefined parameters. And remember, we implemented class P override. If you remember, actually, it's not necessary, but if we remove, we get this warning. So yeah, if you have, if you see this add symbol, that means that's an attribute, and usually attributes, they are used at the develop time by static code analyzer. And that's the main method. Here we can see how we defined a variable. Since we are in null safe mode and we want to let this variable be nullable, that's the question mark used here. Again, new keyword, it's not necessary, and we've got this warning. That's how we create our classes and use params and the constructor call a name method. Print, that's how you do this output to a console. Next, you can see string interpolation. That's the $sign, and then if you you can have some expressions in brackets. Okay, what else we have here? Loops, for loop. Actually, that's the for each loop. We treat through each value in a list, and that's a traditional for loop with the counter. That's how we use random. I guess that's why we had to input Dart math. Well, basically that's it. And if we want to run, we hit the run button, and we should get the output in the right pane. Just in case there is a gist for this code, we can share it after the intro. Okay, that was Dart. That was the language behind the Flutter. Let's talk about Flutter. So Flutter, that's the framework. There are three major building blocks. Dart, that's the building block on the surface. That's the programming language. That's where major part of Flutter is written, but there is a lot hidden behind the scenes. Essentially, there's the Flutter engine, which is built using C and C++, and there is also Skia. Skia, that's the rendering platform, which is, by the way, used by Chrome, by Android, and Flutter uses Skia in order to draw on surfaces. So the Dart part, we've got Dart VM. When you debug the app, you are using the app in this virtual machine mode. You've got your code compiled just in time. That is necessary in order to have hot reloads, hot restarts working. But when you build for publishing, for release configs, then that's ahead of time compiling, and you don't have just in time anywhere. Okay, the Dart piece. We've got this pub dev package manager. That's where both Dart and Flutter packages live. If you check this website, you can see that you can target either Dart or Flutter part of the ecosystem. By the way, Dart and Flutter, those are separate teams. Those are separate products. They are tightly coupled, I would say, because Flutter is the major client of Dart. But still, those are sometimes, you can see those are different worlds. Okay. The Dart part of Flutter, it contains the implementation of widgets, which is essentially a reactive framework. If you used React, that's exactly the same approach, where you have pure components and components in React. You've got stateless and stateful widgets in Flutter. And you've got animation, painting, all of the stuff is implemented in Dart. Under painting, I mean that request to put something on the screen, but the actual rendering, that's already a different part. That's the C#, the C++ part, which you typically don't know about and don't touch until you do some sophisticated stuff as create your own widgets from the scratch. Okay, and Skia is hardware acceleration depending on the platform where the app is running, which again is one of the basis for this great performance promises. And this part, that's Flutter native, that's the stack behind apps which you build for Android, iOS, macOS, Windows, Linux, and Fuchsia. Fuchsia, that's an OS which is supposed to replace Android sometime in the future, but it wasn't worked for who knows how many years. And knowing Google, we might forget about it sometime in the future. But still, like that's the platform behind building native apps. But as well, we've got web, and web while on the surface, to the developer, it might look exactly the same Dart, same widgets, but under the hood, that's a completely different framework. And what Flutter team did, they recreated the Dart part. Now we've got this transpilation from Dart to JS. There are two flavors of this compiler, Dart dev-C. That's when you build and debug the apps and have this fork reloads. Then there is another compiler, Dart2JS, which is used for release builds. There is no Dart VM or ahead of time compiler for reasons, since we've got this transpilation. There are no isolates in Dart.Let, just in case. They completely re-implemented the Flutter engine in JS and HTML, and they replaced Skia. Actually, not replaced, but there are two options how you can render and put the visuals on the screen. You can use so-called HTML renderer, which uses absolutely positioned HTML elements and puts them onto the screen, or you can use the WebGL and WebAssembly builds of Skia. It's called Canvas Skid. That's when you actually use Skia for rendering. Yeah, that's Flutter Wrap. And actually, when you have this requirement to have your app also working for web, at some point, this abstraction might start leaking, and you might be exposed to the fact that web and native, they have very distinctive differences, and you should adapt to those. For example, there are these two packages, Dart.io and Dart.html. Like the first contains such stuff as files, processes. You can listen to web requests. You can write your web server in Dart. In Dart.io, you've got this class or enum, which can show you what is the platform the app is running. On the other hand, there is a Dart HTML package. There you got some basic classes to deal with window or DOM elements. And the interesting part that in your single Dart file, you cannot import these two packages at the same time. You've got a compilation error. And that's where this abstraction starts leaking. And by the way, there is another curious kind of fact. It's typical for cross-platform frameworks. Sometimes have this if statements checking what is the platform the app is running on. And you do not have web in this platform enum. You should use two different approaches. For web, that's using this constant, K is web, and for native is using this platform. So when you need to discern between native and web, you should be aware of this. Another curious fact, like how this K is web implemented. By the way, when you open something in official docs, you typically can see this snippets from the actual implementation of a given member. And K is web constant. That's it's using a hack or a workaround, like in when Dart is running in this transpilation mode to JavaScript. In JavaScript, there are no ints or doubles. There is this only single type called number. All numbers are float numbers. And K is web, like if you're running in native mode, it checks 0 to 0.0. Like it checks, it compares int to float. Sorry. Yeah. And running in web, it will return true, because in JavaScript 0 is exactly to 0.0, but in native it will return false. That's how it's working. Like you can get the idea of the tricks which the team used for this web platform. And I would say that's one of the challenging or problem areas for Dart at the moment, when you have to deal with web and native implementation details. You have to use conditional imports, which are not quite, I'd say, clean and easy to understand. Like that's how you, like in this case, as a developer, I have to create 3 files. Like, for example, if I want to store something in a file, then in Dart native, I will use this file. If I'm using web, I don't have files. I will have to import another version of this file, which will use, for example, IndexedDB or local storage. Yeah, but that's enough on web versus native. Let's talk about coding in Dart. Let's create an app and see how coding in Dart works. Okay. So as you can see, I've used some of the commands available through Flutter and Dart extensions in Visual Studio Code. And it created for me this starter app. A second, let's remove the comments in order not to be distracted. And let me demonstrate this aggressive formatting. You could see that I removed all of the comments. I click save, and now I got this formatting done for me. Let's run the app. That's the standard count app. You could see it many times while learning app or while creating bugs and submitting bugs to GitHub, because that's the app which you will use for minimal reproducible examples. And by the way, I forgot to mention that I am using Apple Silicon and ARM version of MacBook. Dart already supports building for ARM versions of desktop apps, which, if you know this story with ARM and Apple Silicon, which was and still challenge for many IDEs, frameworks, etc. And by the way, the first build might be slow, but due to hot reloads and hot restarts, Flutter is super productive comparing to Xamarin, which didn't have this feature for quite a while, and I believe the current implementation is not perfect. That's a huge difference of productivity. When you switch from Xamarin to Flutter right away, that's a deal breaker, that's a game changer. You can change your code and get the UI change right away. Okay, still building, connecting. Oh, okay, it's already set. It's just we started it in emulator. Sorry for that. Let's build it for native. You know, there is, by the way, this legend that Flutter team, they created this support for desktop native stuff in order not to run power-hungry emulators and to have this easily debuggable apps in Flutter. Okay, macOS build was quick. That's cool. So that's our app. As you can see, that's we click the button and get the counter incremented. Now let's look at the application. Main, run app. That's something similar to what you got in app.js of React. We've got the stateless widget. Again, everything is a widget in Flutter. That's what you hear a lot Each widget has this build method. That's where you return other widgets. In this app, you can see that we return material app. Side note, Flutter comes with material app, Cupertino app, and widgets app. Like they recreated the design language of Apple and material from Android. And if you would like to have Apple looking up, you would start with Cupertino app. Okay, trust me. Besides, you can find other widget frameworks or widget bundles. For example, at one of the Flutter events, there was a demo of Chicago UI bundle, which is tailored to desktop development with a lot of controls tailored to desktop. Okay, so returning to our example, that's where we create yet another widget, which in this case is a stateful widget. Stateful widgets typically have two pieces: stateful, the class inherited from the stateful widget itself, and then the state. Don't ask why, but for some reasons, with stateful widgets, you have to have build method in the state. That's the way it works. But here you can see something similar to React, this set state call. Like if you want to have your widget to build, you have to call this method. And if we go to this button, by the way, let me show you right away how we can inspect widgets. I can click on this button and right away I can see in the inspector something similar to Web Inspector in Chrome, and it also highlights the widget in the code. Okay, let's try some code and let's change the UI. Let's add a feature animating this small number. So let's start with introducing yet another button. By the way, see that we are using scaffold. Scaffold, that's a well-known UI element from the material app, and in Flutter we've got right away a number of shortcuts, such as we might have drawer, we might have some elements such as this floating action item button, and yeah, this scaffold widget, it implements this scaffold element from the material app. Let's add a row. Let's add children, and let's move this floating button to this row. Let's click the save. Okay, right away we got this error. And you can see right away we have the UI changed. Okay, let's change the way text looks. Text align. Text align center. By the way, curious fact about this alignment. Okay, used it in the wrong place. In Xamarin, if you use label and would like to change the alignment of the text, there are only three options available: left, center, and right. There is no justify. And the reason for that is that the native element in Android versions prior to version Android 8.0 didn't have the justify option, and that's why Xamarin had to use the minimal intersection, like whatever is available in both iOS, Android, etc. Like that's one of the disadvantages or problems with renderers approach. When you have this abstraction of elements, you have to pick something which is present in all the frameworks, and not always that's the case. Okay. Getting back to this exercise, we wanted to add yet another button for the animation. Let's use another button. Okay. Let's justify. Somehow it stopped refreshing. Let me reload. Just a second. Oh, I've got some problem. Next, what's wrong here? Okay, let's not waste our time. I have this example prepared for you. Maybe that's the one. Yeah, that's the one. Let's go through what I've already prepared for you. So exactly the same up with the counter, but implementing the new feature. Let's start it and let's go through the code. Okay, so you can see what we did. What I did. I've added this second button, which allows me to start or stop the rotation. What we changed here is that we added, instead of this simple text widget, yet another widget. By the way, in this case, I'm using a hook widget. That's the package which I added to PubSpec. In my opinion, stateful widgets are quite verbose and not easy to use, and especially for animations. That's essentially a take on React hooks. In this widget, we've got this build method, we've got our animation controller, we've got the parameter, constructed parameter, which is given upstream and shows whether the app is running or not, the animation is running or not. We've got this floating button on pressed event handler, where we do set state of a member run animation, and down the stream we use this field in order to change the icon, just as this, the color, and most importantly, we've got this run animation field, which again is set in this key handler, on press handler. We set this param for our stateful widget, in this case, hook widget. Yeah, and that's how we start the animation. And by the way, I think we can change right away and have this hot floats working. All is good. That's it about the example. I haven't put it on GitHub, but still, if necessary, I can do it easily. That was it about giving this live demo of coding with Flutter. Theory, UI basics. So again, React approach, everything is a widget. In terms of building the UI, we've got widgets which are immutable. Each widget presents the configuration of the UI. Then behind the scenes, there are elements which are mutable, and like with each build call, we recreate the tree of widgets, but elements, those are expensive and heavy. Those are associated with the widgets. And again, that's COPE is this React virtual DOM approach, when you've got React components and you've got DOM elements which are being mutated by the framework. And then we've got render objects that a lower level stuff in the rendering pipeline. We've got this aggressive composability, which means that if we need something in the UI, for example, padding, we need to add empty spaces for these buttons to the left and to the right. We've got this widget for this padding. And you typically won't find some styling attributes in the widgets, which are typical for web development or for Xamarin. But in Flutter, look for a widget for this stuff. Besides, there is no CSS, there are no styles or themes. Sorry, there are no styles. You use themes, which is different. Okay, that's the aggressive composability. Widgets, Cupertino, and Material App. That's something we touched. There is Flutter Gallery app, which you can use in the browser, which you can download in Google Play. That's where you can play with actual widgets from any of these bundles of widgets, Material, Cupertino, etc. Okay. Go next, Flutter Insights. Some of the observations. When you build, when you code and develop with Flutter, you get complete sources of Flutter on your computer, unobfuscated, non-minimized. You can go to definition, and you can see that I'm actually now looking at the source code of Flutter itself, of the widget. Okay. Same stuff about the plugins or packages, whatever you import from using this pub/spec YAML. You can go to the definition. You can set a breakpoint in the plugin, the code of Flutter itself, which is very useful. And by the way, you can define here in Visual Studio where you would like to have your exceptions code at which level in your code, in the packages, or at this SDK side. There are two channels, Flutter Stable and Beta. There was a dev channel, not actual anymore, and also there is this master channel. Stable channels typically rolled out quarterly, Beta monthly. Some history note. prior to March 2020, beta was web platform was beta, now it's stable. Prior to May 2022, desktop was not stable, now it's unstable channel, and also it's possible. If you go through docs at official websites, those docs, they actually compiled from this inline docs, 3 slashes. If you create your own packages and decide to publish to pub dev, again, that's where you put your docs. Those docs are inline. Flutter DevTools, I've showed you this widget inspector. You can do performance profiling. You can do memory profiling. You can do UI inspection. So it's already there. You can use it. Though, like my impressions is that it's still far from what web tools provide you in terms of troubleshooting and looking at code, etc. Test automation. So in Flutter, we are asked to put all our tests in this test folder. We can do unit testing, we can do widget testing, and we can do like end-to-end testing with emulators. So Dart test package is there if you would like to do the unit tests, create class instances, check their state. We've got Flutter widget tests. That's when you essentially build UI in a headless mode, when you don't do anything, but you can check what widgets are created, what is their state, what are the elements behind those widgets, etc. So those are fast UI tests with in-memory representation of the UI. And you've got Flutter driver, which is similar to Selenium WebDriver, when you can run your app on an actual device or virtual device. Besides, you can use Firebase. That's not something specific to Flutter, but to any app. It might be useful for any app developer just to run your app through this monkey test on actual devices and see whether it draw any critical errors or crashes, which might happen by clicking on some random pieces of your application. Again, personal impressions wouldn't spend much time here, but I would say that after Xamarin, Flutter looks fresh, looks engaging. It brings you this, I would say, sense of achievement and excitement. I would say it seems like something built for young people. Like there are YouTube shows, there are this widget of the week, short YouTube videos, 1-2 minutes explaining what certain widget is. So yeah, like my personal impression after trying Flutter and moving from Xamarin, that's for sure something way better. Though there are actually some problem areas with Flutter. Those are the ones I could put up, or like if you come from Microsoft ecosystem, their documentation is superb to what you have with Flutter and Dart. Sometimes you cannot find answers. So for example, isolates. If you want to do concurrent development, you will spend a lot of time doing your investigation. Parallelism. In .NET, you've got, for example, parallel link or TPL, task parallel library. You can benefit from parallel collections and use multiple cores in order to have your code running faster. In Dart, since you don't have shared memory, Many of the algorithms which benefit from not threading, they cannot be implemented like at all, which can be a challenge when you would like to use the full power of multi-core CPU. But for web developers, that's not a problem. Like web was always single-threaded. That's something which is not a problem for web developers. Flutter Web, it doesn't have the native fill. If you think of using Flutter as a replacement for Angular or React, be careful because the result you might end up might be not up to the expectations. We can touch this a bit later. Another problem with Flutter, there is no single language in platform projects. That's comparing to Xamarin. You can, if we talk about going and changing something in Android or iOS project or Linux or whatever, in Xamarin, you will still be using C#. You might be using Android SDK classes or AppKit, UIKit, but still you'll be using the same language. With Flutter, if you happen to be dealing with some native stuff, be ready to use Kotlin, Swift, C, whatever is the language used for a specific platform. Styling with themes can be a challenge. Like if you look at the widgets at their code, you can find quite often this theme of context, and then getting a specific value for a color or for a margin. Like themes in Flutter, those are hierarchical collections of key values, like what's the button theme, buttons are typically this white, this color, etc. And why it can be a challenge, it is not always clear what is the exact value of a theme you should change in order to get your button look in a certain way. For example, if you happen to be changing some themes, creating your own, for example, in this case, I create my own light theme by cloning the standard light theme and then overriding. You cannot simply point and click and see what is the field in this theme in order to change, let's say, the size of a text in a button. That can be a challenge. Dart is not as feature-rich as C#. That's true. A Flutter ecosystem is not as rich as .NET. For example, like if you do UI development with Flutter, you are good to go. But if you have to do some stuff, let's say generate a PDF, integrate with some stuff, you simply might not find a proper client library or package for Flutter. Currently, Nugget for .NET, it has almost 300 packages. But pub.dev, it has 10 times fewer packages. Another example, 1 year ago, I was looking for a package in order to deflate task for a byte stream. I wanted to do some benchmarking, choose which algorithm works better for my scenario. I only found 2 packages for Dart, and the number of available algorithms, it was not, I'd say, it was not the ideal one. There were a few options. So yeah, using Xamarin for mobile development, you're also relying on a 20 years of .NET development. Flutter is just 3 or 4 years, Dart is probably 7 years. And be ready that some integrations, some stuff outside of the UI, it might require you go in and find some native libraries, integrating with them, using some platform channels, form function interfaces, which is a challenge if you are not good with native development. Yeah. Flutter for web. Few notes. If you open a web app, you can select whatever there is. In Flutter, you cannot select text by default. Like that's might seem as a simple stuff, but still, like that's something you will never be able to implement in Flutter. If you want just to click Control A and copy whatever is in the page, that's not doable in Flutter. Like never. That's something deep in Flutter, and that's something that you will never implement. And there are actually many of this stuff which you might notice. For example, you can start moving an arbitrary element in web. You can have this drag and drop. In Flutter, you should have this explicit drag and drop interactions. You cannot tap on an arbitrary item and have it moving. Another problem, I would say it's a big problem, scrolling is jagged. Like if you have huge lists and if you are not using Chrome, that would be noticeable. And you still can find in the docs that Flutter is still best viewed in Chrome, which is a challenge if you want to have Flutter as a key platform for web development. Debugging for web could be unstable. Like my experience was poor. Sometimes breakpoints could be missed. Values cannot be seen. Might be better, but didn't check it. Build times greater than in case of React. Like React, it's instantaneous. Flutter web, as long as you don't use reloads, it can be slow. There is little for desktop currently among standard material and material widgets. You don't have context menus. You have issues with right clicks. Like you might spend some extra time searching for a widget or doing some stuff. Okay, let's talk about SVG. Like you can. As a web developer, you can use SVG without any hesitation, put it anywhere. In Flutter, there is no out-of-the-box vector graphics format except of fonts. And fonts, they are monochrome. And if you would like to have colorful vector graphics, you should go outside of Flutter and search for options. There is a package for SVG rendering. There is this tool called, if I'm not mistaken, Rive, which allows you to create sophisticated animations. Okay, no CSS, already touched this. Theming is way less powerful than using CSS in web, that's for sure. Docs, flutter.dev, widget of the week, API references, that's a good point to start. Just a thought experiment. Imagine that you are a startup that needs to build a app which targets multiple apps. And if you would like to go with native, then you should have a separate developer stack for the backend. Then you've got a separate developer stack for web. For iOS, you've got Swift. For Android, you've got Kotlin. Android SDK. Essentially, like currently, Flutter allows you to have all of these client apps written in single code base and do it effectively, efficiently. Like in this scenario, you can end up with one front end and one backend developers creating an app which can run like the majority, 99% of the platforms, client platforms there are out there. And the question is there any other framework which has the same coverage? To my knowledge, there is none, at least with the support of where the key maintainer supports all the platforms. Like with Xamarin, there is no web. There can be some experimental bindings which do not work. In React, there are no bindings. In Blazor, in React, there are no bindings supported by Facebook. In Blazor, there are some experimental bindings by some other developers, but no other framework has this touch and attention and maintenance for all the platforms from the major maintainer. And to my knowledge, no one promises those platforms as stable as Flutter currently does. One last slide, like iOS, Microsoft, they have had Xamarin for quite a while. Now they got this rebranding of Xamarin, which is called MAUI, Multi-App UI, but still most of their mobile apps, they are written in React Native. They do not use their own tool, which kind of shows whether the tool is good or not by their own evaluation. Whew, that's it. Sorry, it took longer. 2 minutes over the planned time. That's it from me for today. Are you still with me?
Thank you very much for your talk. So it took a bit more than I expected, and probably we won't have time to answer all of questions because there are a lot of questions. Firstly, I see that I saw that questions that we have not a lot of questions, but then I understood that not all of our watchers watch us on YouTube. Some of them watched us in via community platform, and when I opened it, I got, I don't know, 100 questions. it's too much for answering right now. Let's choose some of questions, answer them, and other questions we can answer offline. For example, you always can find me in Twitter, or if you work in EPAM, you can find me in Teams, of course, some Denisov and Maxim as well. So the first question that we have in the YouTube, that in the beginning of the talk, you show that Flutter gives opportunity to launch applications on many platforms. And Buzi Arban asked us that is familiar to Compose. And why do you need Flutter? What's the difference between Compose and Flutter? Did you?
Well, I know little about Compose, but I believe Compose doesn't have web support. And who is the maintainer of this web platform? Okay, well, might be, I don't know, would be curious to have some intro to Compose and see whether it's good for cross-platform development. But when I had this problem when I created my app with Xamarin and built it for desktop, I could see that iOS and Android they were the primary citizens of this ecosystem, and desktop it was not stable, many bugs, unpredictable behavior. That's something I didn't see in Flutter. Like all those platforms, they are stable, they are maintained, and they are way more predictable than Xamarin. I don't know about Compose.
Yes, and about Compose, it's what can I say? Flutter is much mature than Compose because Compose we got a bit later than Flutter. And using Compose, for example, we can't create application for iOS. iOS that support by Compose, and Compose is developed by two companies: Jetpack Compose developed by Google and TikTok Compose by JetBrains based. That's why, in my opinion, for this time, it's a bit less stable. But if you're familiar with Kotlin and don't want to deep in the Dart, probably Compose could be your choice. But
so I believe that's these four platforms: Windows, macOS, Linux, Web, and probably somewhere near is the Android.
Yes, Android is Jetpack Compose. It's a bit different, but it's Android UI. It works with.
Yeah, but you don't. Yeah, but you don't have iOS and you don't have macOS in this case. Oh, you have
Yes,
macOS.
everything from Apple ecosystem. You don't have something. To be honest, using Flutter, it's possible to make application not only for macOS and for iOS. For example, it's possible to do some tricks and build application for TVOs and watchOS, for example. And of course, it's impossible with Compose. So let's move on. Question in YouTube. Bjorn also had a question regarding your benchmark. In his opinion, the benchmark is especially to show the Flutter the best. Is it true?
No, that was like the case. I started with Xamarin, if I'm not mistaken, and build exactly the same. Let's go to test. For example, I can show you quickly the code. It's trivial, like calculating the positions and then adding, appending each other, removing each other. So no, I didn't have any predetermination about Flutter. That was my first actual experience with Flutter. Actually, I remember when I published these results to Reddit, like though test comparing platforms, there was a question, why don't you try building it for the web, like Flutter Web, how it will work? But I don't remember that I actually tried this. So it might be the case that Flutter Web might be a loser in dope test while being a winner in native mode.
Okay, thank you. So one more question. Maxim, thanks for demo. How powerful, which workstation are you considering performant enough to run all the simulators?
This like I've shown these examples on MacBook running M1, which I think quite powerful. But last year I did the exact same demo on 2018 MacBook Pro, also ran well. It ran well, no problems on Intel Mac.
Okay, and we have a question from Zlati. You told that C is a language that work in all platforms. Now, what did you mean?
Oh, not sure. I might have kind of just like I might have told something I didn't mean. Like I'm not sure what this means. Like C language can run anyway. I can just could just make a mistake. So I actually don't get what the question is about. I'm not sure I remember what I thought about C.
Probably in the documentation there's information about some kind of NDK level. For example, you can execute C libraries on Android and on iOS on NDK level, and Dart support execution of this kind of libraries using Dart FFI, foreign function interface.
But
if you're talking about Linux, Windows, and macOS, there is almost the same because macOS also supports Linux support and Windows support. Probably we did say about this. And Lachi, if you have questions about, sorry, I'll remove it. Probably you did understand incorrect what Maxim did mean. Okay, we have no more question in you. Sorry.
Yeah. Like speaking of C or Rust or whatever, like there are languages which can be compiled to the largest number of platforms take Rust, which again can be executed in a myriad platform. But what are you going to be building? Some libraries compiled for these platforms, which get some parameters, return your data, or you can create console apps. But that's a different story when you create UI and you have to have all of those libraries integrated with APIs with certain platforms. You should have those UI controls wrote as executables, as apps. That's a completely different story. Like building a cross-platform library is way simpler than building an app for a platform. But no one actually argues that C can be compiled to any platform, and I believe Qt is the app framework which uses C as a primary language. So if you work with C, you might want to check Qt for building UIs.
Good. Thank you very much. Okay, we have no more time, but let's answer two last questions. The first is a Flutter a good choice for PWA application, in your opinion? PWA.
Yeah, well, you know, like the question is what are your requirements and whether there are certain use cases which might show Flutter in poor light. I don't see why you cannot use like Flutter for PWA if PWA seem to mimic mobile app behavior and no native web stuff is expected, then I think that's a perfect case. But if you have some web features not present in Flutter, then yeah, you might have a challenge like this text selection. Like if you want to select a table somewhere in your app, you might not be able to do this with Flutter. Like no chance.
Yep. And okay, the last question: how to contribute to Flutter? Yeah, I think the answer is very easy.
Oh, actually, I can see three ways. Like the easiest, you can create issues, or you can create comments in the issues. That's what I did. You can create your packages and publish them to PubDev. Again, that's what I did. Or you can create a PR. That's something I didn't do because if you read the requirements to PR, that's I would say you should invest some time up front setting up all the build pipelines, checking how to run all those tests, integration tests. It seems like a lot of work, but as a challenge, might be a good challenge. Have Flutter built locally, have find some issue hanging there for a long time, and submit an APR which touches all the checkboxes.
Yes, that's a nice answer. Thank you very much. So, unfortunately, we have to finish our stream today. We have no more time. Again, we didn't answer to a lot of questions. You can ask us directly. Find us in Teams for EPAM employees, and you can find myself on Twitter. Thank you very much for your attention. Have a nice day, and see you next time.
Thanks a lot. Yeah. Goodbye.